Hi all, let's start Mathematics Grade 6 Chapter 9 Symmetry. Learning objectives. After this session, learners will be able to define the term symmetry, identify and draw line or lines of symmetry in given shapes. Introduction. Look around you, you may find some objects catch your attention. Some of the things are as below. Flower, butterfly, rangoli, pinwheel. Here, are you observing any similarity? See, if I draw a line here, then I can see that this is symmetrical. Here also this way also I can draw. This way also I can draw. This way also But for the butterfly, only one line I can draw. For rangoli, I can draw 4 lines. But for pinwheel, I can't draw it. So now you might have understood what is a symmetry. Symmetry means it refers a part or parts of a figure that are repeated in some definite pattern. So if you observe here by the butterfly, this left hand side and this right hand side, it will be similar. So if we wrap it of that picture, butterfly picture, it exactly coincides. Similarly for rangoli and flower. Line of symmetry. A line that cuts a figure into two parts that exactly overlap when folded along a line is called a line of symmetry of the figure. For example, for this one, vertical line is line of symmetry. So it's there, right? Line of symmetry is present for this one? Yes. Is line of symmetry is present for this one? Answer is no. However we fold, it's not possible to overlap. Figure it out. Do you see any line of symmetry in the figures at the start of the chapter? And what about in the picture of the cloud? See, we observe this few figures, right? Let us see here. Now, how many lines of symmetry is there? Flower. Then 1, 2, 3, 4, 5, 6. So, there are 6 lines of symmetry for this figure. For this butterfly, there's a 1 line of symmetry. For rangoli, there are 4 lines of symmetry. For pinwheel, there are no lines of symmetry. For clouds, there are no lines of symmetry. Question number 2. For each of the following, identify the lines of symmetry if it exists. For the first one, does it exist? Yes. 1 line of symmetry. For the second one, there is a 1 line of symmetry. For the third figure, there are no lines of symmetry. For the fourth figure, there is a 1 line of symmetry as shown in the figure. For this fifth figure, there are no lines of symmetry. Let us see. Figures with more than 1 lines of symmetry. Does a square have only 1 line of symmetry? Take a square paper here. Fold it out vertically. Again refold it. Fold 2. Fold 3. In this way as shown in the figure. Fold 4. Now if you observe here, how many lines of symmetry? There are 4 lines of symmetry. So it's possible that for any figure, there are more than 1 line of symmetry is possible. A square is an example. Figure it out. In each of the following figures, a hole was punched in a folded square sheet of paper. Then the paper was unfolded. Identify a line with the paper was folded. Figure D was created by punching a single hole. How was the paper folded? See here, for the first figure, vertically we have folded. Second figure, is diagonally we have folded. For the third figure, horizontally we have folded. For the fourth figure, it has only single punch. So we have folded twice it up. First vertically, then horizontally. Then we have punched single time. That's why it indicates 2 lines of symmetry. Figure it out. Question number 2. Given the lines of symmetry find the other holes. So line of symmetry they have given. We need to find this other hole. Solution. First one. See if you observe figure A. This is just other hole. For this B, the top line is on the top of the line. There is this hole. For the figure C, on the right side of this triangle, this hole. For the figure D, this down. So this if you consider this as a diameter, this is a circle, then this down here going to be this. This figure E here towards the left side of this one. Figure it out. Here are some questions on paper cutting. Consider a vertical fold. We represent it this way. Similarly, horizontal fold is represented. So let us take a paper here. Then fold it up horizontally. This is called as a horizontal fold. Fold it up vertically. This is the vertical fold. Figure it out. After each of this following cuts, predict the shape the hole and paper is open. After you have made your prediction, make out the cuts and verify the answer. So take a first one here, take a fold here, paper, fold it out, then we need to cut. Paper B also, question B also, like you have to take this paper like this and you have to fold it up. Paper C, first we are folding it vertically, then horizontally, the 4 folders. Paper D, vertically, we are doing it up. Let us see answers, how the figure is going to come for us. Solution. We're going to get the first one like this, A, and the B figure we are going to get as shown in this one. The figure C, as we have folded this 2 times, so we are going to get the 4 parts of like this. Paper D, we are going to get like this. So verify, you can verify to practically by folding this paper. Figure it out. Suppose you have got each of these shapes with this, some folds and single straight cut. How will you do it? See, first one I center in the circle. This is second one also a hole in the center of a square. So let us see how we are going to get it up. First step, fold here diagonally, then refold it out as shown in the figure. Then you cut on top of this one like small corner kind of that one. Then once you unfold it out, you are going to get a square figure. Similarly, to get the second figure, B figure, first you fold it out vertically, then fold it out horizontally, then cut at the corner. So then you are going to get this figure as shown. Question number 6. How many lines of symmetry do these shapes have? In subsection 2, a triangle with equal sides and equal angles. Subsection 3, a hexagon with equal sides and equal angles. First let us see 6, 1a. See, figure 1, this 1a has 4 lines of symmetry. Line 1, line 2, line 3, line 4. 1b has 4 lines of symmetry. Line 1, 2, 3, 4. Subsection 2, a triangle with equal sides has equal angles and this has 3 lines of symmetry. 1 line, 2 lines, 3 lines. A hexagon have 6 lines of symmetry as shown in the figure. Line 1, line 2, line 3, line 4, line 5, line 6. Figure it out. Trace each of the figure and draw the line of symmetry if any. Let us see. First one here. This is line of symmetry is vertical. For the second one, line of symmetry is horizontal. For the third one, vertical and horizontal. For this fourth one, vertical, horizontal. For the fifth one, we have 4 lines. 1, 2, 3, 4. For the sixth one, we have 2 lines. For the seventh one, we have 1 horizontal line. For the eighth one, we have 4 lines as shown in the figure. So this is this lines of symmetry. Question number 8. Find the lines of symmetry for the column below. See here this column is here. There are 3 lines of symmetry for the column as shown in the figure. 1, 2, 3. Figure it out. Draw the following. A triangle with exactly 1 line of symmetry. A triangle with exactly 3 lines of symmetry. A triangle with no line of symmetry. Is it possible to draw a triangle with exactly 2 lines of symmetry? Solution. An isosceles triangle has exactly 1 line of symmetry. See, if we observe an isosceles means a triangle with 2 equal sides. An equilateral triangle has 3 lines of symmetry. Equilateral triangle, all sides are equal. So, we are keeping it of this. Line 1 is symmetry, second line of symmetry, third line of symmetry. A scalene triangle has no lines of symmetry as shown in the figure. See. And this, is it possible to draw a triangle means? No, it's not possible to draw a triangle with exactly 2 lines of symmetry. If it is an isosceles, we know that only we can draw 1 line. If it is an equilateral triangle, we can draw 3 lines. If it's a scalene, we don't have any line of symmetry. Thus, it's not possible to draw a triangle with exactly 2 lines of symmetry. Let us see question number 10. Draw the following. In each case, the figure should contain at least one curved boundary. So as curved boundary is necessary, a figure with exactly one line of symmetry. B, a figure with exactly two lines of symmetry. A figure with exactly four lines of symmetry. So a figure with exactly one line of symmetry, that's the curved boundary, is as shown here. Top is a curved boundary, so one line of symmetry. Second figure, a figure with exactly two lines of symmetry is here. On the right side and left side we have the curved boundary. And this we have two lines of symmetry. One is vertical line, second one is horizontal one. Next, subsection C, a figure with four lines of symmetry. With the four curved lines. See here, this four curves, and this the lines of symmetry is first line, second line, third line, this four lines. So it has four lines of symmetry. Question number 11. Copy the following on a squared paper. Complete them so that the blue line is a line of symmetry. Problem A has been done for you. See here, they already completed problem A for us, dotted A. Now let us write for this problem B, C, D, E, F. As we observe here, first if we are observing here, there is a line here. So similarly we have to draw down like this, then horizontally, then down, once horizontal, then go to the diagonal way and this reach. If we fold it up horizontally, then we can complete it this line of symmetry. Similarly, now diagonally this is a line of symmetry, blue line. So we have to draw figure like this. Next, for this figure D, vertical line is this line of symmetry. So we have to draw a slanting line of this like this. This is this figure. The figure E, horizontal line is line of symmetry. So we have to draw like this. First one slanting line, again going towards the left side, one more slanting line as shown in the figure. Then join this one. So now this is this figure. Now for the figure F, write horizontal here, come down, then diagonally drag down, then horizontally, then go up as shown in the figure. So now this is, so all you have completed. Figure it out. Question number 12. Copy the following drawing on the square paper, complete each of them so that the resulting figure has two blue lines of symmetry. Now for each of the figure, if you observe, all the two lines are there. So we have to complete a figure in such a way that it has two blue lines of symmetry. So we have to copy it of this one. First figure. If we observe, as we need this, going to be this two lines of symmetry. This line is there, so just do it the same, it is in the form of the square. So we got it up. If we fold it up vertically, diagonally, and also like it will be like symmetrical, this one. Two diagonal ways. Line 1 and line 2. These two lines are symmetrical now. Similarly for this one, just use the same way. Now if you fold it off, first one diagonal way, second diagonal way, this figure is going to be symmetrical. For the third line, one line is horizontal, one line is vertical. So you extend it of this left side, then mirror image of that one, you do it on this. You are going to get it out. Next, for the fourth figure, the lines of symmetry are horizontal line and vertical line. So mirror image you have to do and extend upside it, shadow. For this fourth line, horizontal and vertical lines are lines of symmetry. So just mirror image down, this shadow is this other side. This last one, so just as horizontal and vertical lines are there, so we need to extend this figure, then mirror image. Figure it out. Question number 13. Copy the following on a dot grid for each of the following. Draw two more lines to make the shape that has this line of symmetry. So to ensure that one, as already the first figure, this is two lines. So we need to complete this with two more lines. Solution. To get this exactly symmetrical, let us start here with the blue line, see, as shown in the figure. Now this vertical line indicates this is a line of symmetry. So if you fold it up, exactly it matches. For the second figure, extend this one to this one, blue line. Then this vertical line, the black one is this line of symmetry. For the next one, just from the top you bring down. So this is this black line is this line of symmetry. This if you fold it up, you are going to get it. For the next figure, Just draw line here, then make slanting line here. This vertical line is line of symmetry. Similarly here the black line, then the blue line is this. You need to complete this symmetrical lines. So this black line is a line of symmetry. Now this horizontal black line is this line of symmetry, and the blue line you are making this one to make this figure is symmetrical. So hope all these 6 you achieved. Thank you.